In this video, let's look at a sample code that illustrates virtual functions in C++. This is a piece of code that illustrates use of the keyword virtual in one of the classes. So let's look at the constructions here. We have two classes, class A and class B. And notice that class A is the parent class, notated by this rectangle. And then we have inheritance pattern, where class B inherits class A. And this is illustrated here. Class A, class scope, inheritance, public class A. So the inheritance pattern here is via public inheritance. There's one method in each of the classes, and that method is called void show. This show prints out what belongs to that class. What's in A? The show function in base class invoked. So this is a base class, and this is the derived class. What is in B? Show function is the show function in derived class invoked. Now let's look at the driver, the entry point main function. We create a pointer to A. We then instantiate an object B pointing to class B. So this is statically declared on the stack. So it's this one. Your pointer A sits on the stack. What we're doing next is we assign A equals to the address of B. This means the memory address of B is stored in A. So this is class A, visually speaking, and this is class B. You have 8 pointing to it. This is the pointer to class A with a memory address 21. Your memory B has a memory address FA40. So now your variable A, which is a pointer, has the memory address of this. Now when A, since this is a pointer, we use the arrow, calls show. Is A going to be pointing to the show in your base class? Or is A going to be invoking your show function in the derived class? The question is answered by looking at this virtual keyword. The reason why there is a virtual here, this virtual states that this entire show method will be overridden by any derived classes of A who chooses to implement this show in their own respective class, which is exactly what happens. Class B chooses to implement show, which was declared as a virtual in class A. This makes class B the de facto class driving this method. Therefore, even A now has the memory address B. When A invokes show, the derived class show method takes over. So in fact, if you run this code, this show would invoke this show here instead of the show method in the base class. There are several key takeaways. Number one, a virtual function is a member function that you expect to be redefined in derived classes, such as here. We redefine it in a derived class. When you refer to a derived class object using a pointer or a reference to the base class, like this, you can call a virtual function for the object and execute a derived class's version of the function, such as in the case of these. So number one is virtual function is expected to be overridden in base class. Number two is once overridden, the overriding method is expected to take over that method when the base class pointer is called. Overriding method or function will take over. The question is, why do we use virtual functions or methods? Well, we use virtual functions or methods to ensure that the correct function is called for an object, regardless of the reference type used to call the function. In this case, A obviously is pointing to B, however, B's overriding function is called. They're basically used to achieve what's called runtime polymorphism. And runtime polymorphism ensures that these virtual functions are declared in the base class by using the virtual keyword before the function. You'll see this a lot in OOP, specifically C++. Now, you don't see this virtualness in C because C doesn't provide native support for OOP. C is a procedural, not object-oriented. However, you can emulate virtual functions in C still, but that work is beyond the scope of this class. In summary, what are virtual functions used for? The virtual function is a member function in the base class that we expect to redefine in derived classes. Basically, a virtual function is used in the base class in order to ensure that the function is overridden. This is especially important when it applies to cases where a pointer of base class points to an object of a derived class. As you can see in this code snippet, there's a couple of rules for virtual function, and these rules are: one, the function cannot be static. So you don't see any static keywords here. Static does not belong to the class. It belongs to the entire running program. And when you derive these virtual functions, you got to use the virtual keyword. That's rule number 2. Rule number 3 is virtual functions in C++ need to be a member of some other classes, such as your base class. You cannot declare virtual on function outside of a class. So the keyword virtual needs to be used in the context of some member functions inside a class. This completes our discussions on the virtual function in C++. Let's run this code in our IDE next. This is the same exact code that we had, where we have class A being a derived class, inherited by class B. You have a virtual function called show, which is implemented in your class B. And by way of running it, we should be expecting to see the overriding function show to take place. Let's run it. As we can see, the show function in direct class is invoked. This is what we call runtime polymorphism, as explained previously. Let's do something else. Let's get rid of this virtual. We're not going to change anything in the main function. And let's run it. As you can see, the show function in the base class is invoked. This is because A is a pointer to class A. Therefore, when A is used to invoke its show method, we see the show function in base class invoked. There is no runtime polymorphisms here. This is simply how object works. It's an object of class A. So when you invoke its method show, which is not virtual, that method is called. This had nothing to do with inheritance. This has nothing to do with polymorphism, even though A has an address of B. Class A in and of itself is still class A. Hopefully this illustrates the difference between virtual versus non-virtual in C++ and how virtual plays an important part in runtime polymorphism in C++. This concludes our lecture. We'll talk about pure virtual functions next.